So in this video, I'm going to go through some applications of variation. So this is a video that pairs along with one of my lesson videos on variation. So I assume that you at least are familiar with that. If you have no idea what variation is, I would suggest watching one of my lesson videos. So I'm going to go through these three examples, so you can pause and read them over if you'd like. Otherwise, I'm just going to jump right into them. So starting with the first one, so the circumference of a circle varies directly as the radius. A circle of radius 8 inches has a circumference of 50.27 inches. Find the circumference of the circle if the radius is 5 inches. Okay, so you probably already know the equation for the circumference of the circle, but this is a variation problem. So the circumference, let's call that C, C, varies directly as the radius. Okay, so directly means that we multiply by k, so let's call this kr. So now I'm given some information. I'm told that a circle of radius 8 inches has a circumference of 50.27 inches, so I plug in 50.27 for the circumference, and I plug in 8 for the radius. And then if I just divide both sides by 8, I get that k equals 6.28375. But if you were to just calculate the value of 2 pi, so if I plug it into my calculator, 2 times pi, that comes out to about 6.283185. So it's pretty close. So these are all rounded answers, so we're not going to get exactly 2 pi, but this really does just come out to be 2 pi. So if you think about it, the circumference of a circle is 2 pi r. So 2 pi is the constant of variation. Okay, so now find the circumference of the circle if the radius is 5 inches. So I just plug 5 in. And in this case, I get that this is 31.42 inches. Okay, the current in a simple electrical circuit varies inversely as the resistance. If the current is 30 amps when the resistance is 10 ohms, find the current if the resistance is 5 ohms. Okay, so we'll call current C, and this varies inversely as the resistance. So K over R. Okay, so now if the current is 30, so I plug in 30 for C, when the resistance is 10, okay, so if I plug that in, now I can solve for K. And to solve for K, I just multiply both sides by 10 to get that K is equal to 300. So now I have the equation 300 over R, and it says find the current if the resistance is 5. So if the resistance is 5, this will give me a current of 60. And finally, so the volume of a gas varies inversely as the pressure and directly as the temperature. So now we have combined variation. If a gas occupies 2.6 liter, it occupies a 2.6 liter volume at 600 kelvins, and that's a temperature, by the way, and a pressure of 24 newtons, find the volume at 240 kelvins and a pressure of 32 newtons. Okay, so volume, we'll call it V. So we've got K here, so let's see, varies inversely as the pressure, so inversely means divide by P, we'll say P, and directly as the temperature, so also multiply by T. So there's the general equation. So now I'm going to use all of the information in the next sentence. So we have a 2.6 liter volume. The temperature is going to be 600, and let's write 600 K, 600 times K, and a pressure of 24. So here's what I have to solve. So I can start by multiplying 2.6 by 24 to get that this is 62.4 equals 600 K, and then divide that by 600. So I get that K comes out to 0.104, so a very small number. So now I have V equals, let's see, 104 T over P. Okay, so now I can just plug in the next part of this. Find the volume at 240 kelvins and a pressure of 32 newtons. Okay, So let's see, 0.104 times 240 over 32. So let's see. The volume in this case will be 0.78 liters. Okay, and so those are just a few examples to show you how to set up a couple different applications. So I'll leave it there and I will catch you guys in another video. Thanks for watching.